In this video, we are going to see example of double integration method. So you see a cantilever beam is uniformly distributed with the W, which is a load per meter. Here total length is L, and if we calculate the moment at a random x point, then moment at x will be negative because it is a hogging position. The deformation will be like this of this cantilever beam. So negative of wx is a load on this, so W times the length of this, so this much will be the load, the area of the load in this x, and it will be acting at x by 2 distance from this point. So at this point, W by 2 into x by 2, that will be the moment at x. So it comes out as minus wx square by 2. Now if we use the double integration equation, then ei d square y by dx square is equal to moment at x, which is this minus wx square by 2. Now we have to integrate it twice. So one time if we integrate it, then we get dy by dx equal to the dy by dx equal to theta, which is slope of this curve. So is equal to minus wx cube by 6 plus c1. So we have integrated this term. Now if we integrated one more time this entire term, then we get eiy. This eiy is equal to minus wx raised to 4 by 24, 6 into 4 is 24, plus c1x plus c2. So these two, c1 and c2, are constant. We have to find c1 and c2. Now to find c1 and c2, we have two boundary condition. We know that at x is equal to 0, from that x equal to L. So at x equal to L, we have y equal to 0, there is no deflection, and we have theta is equal to 0. So slope and deflection at this point is 0. So now if we place theta is equal to 0 in this equation, so 0 is equal to x equal to L. So minus WL cube by plus C1. So C1 comes out to be this value. And if we similarly do at x equal to L, y is equal to 0. So this term is 0. This term will be minus WL is to 4 by 24 plus WL cube by 6 from this equation. C1 we are placing in this equation into x is equal to L plus C2. So C2 comes out to be minus WL raised to 4 by 8. Now if we place both C1 and C2 in these two equations, we are left with these two equations. So these are the final equations, and this is for slope and this is for deflection. Now we know that to find maximum values, the maximum deflection and slope will be at x equal to 0. So from here x equal to 0, we have to put x equal to 0, theta will be theta maximum, y will be my y maximum. So if we put x equal to 0, we are left with this term. So theta will be equal to WL cube by 6 ei will go on this side, so 6 ei. Similarly, if we place x equal to 0 on this equation, these two terms will be 0, and y maximum will be equal to minus WL to 4 by 8 ei. So these are the two equations. This is how we have to solve each and every numerical. First we have to calculate this moment at x randomly, and then we have to place this in this equation. Then we have to integrate twice, put the boundary conditions, and we get the solutions. And to find particular value, we have to place value of that x. Here we want to find maximum value, so that will be at x equal to 0. So this is the problem for double integration methods. Thank you for watching this video. See you in the next video.